All right, guys, so 2-1 is called solving basic quadratic equations. And there's a few things that we need to learn before we actually get down to that. If you look at the note page, we're going through 3 boxes before we even get down to the one titled solving equations. So first of all, what is a quadratic equation? A quadratic equation has an x squared in it. That's pretty much it. So last year, you did what were called linear equations, and linear equations had an x. Sometimes it had a 3 in front of it. Sometimes it had a negative fraction in front of it, but you always had an x value. This year, we're working with what are called quadratic equations, so you will always have an x squared. Sometimes there's a number in front of it. Sometimes there's not. Sometimes you also will have an x value. Sometimes you will also have a constant, but not all the times. What makes it a quadratic equation is that x squared. Nothing else around it matters as far as making it a quadratic equation. So, what you need to know to start solving these things, first of all, let's talk about square roots a little bit because that's a big part of how we solve these equations. Remember, the square root symbol looks like this. The square root is the opposite of squaring. So if you were to square a number, the opposite of doing that would be to square root. Just like multiply and divide are opposites, squared and square root are opposites of each other. Okay, so over here in the notes it says, notice that the square root of 64 equals 8. And that is because 8 squared equals 64. One of these undoes the other one. The square root of 9 is 3 because 3 squared equals 9. So you've got a couple squares right here on the right. Now remember, to find the area of a square, you take the two sides and multiply them together. So this first square that has an area of 25, we found that by doing x times x. In this case, when we did that, we got 25. So if I wanted to go backwards and figure out what these sides are, the opposite of taking x times x and getting 25, because remember, x times x is just x squared. So the opposite of doing square is to square root. So if I square root 25, then I find out that each of these sides is equal to 5 because 5 times 5 equals 25. The square that is 81, if I want to know, that has an area of 81. If I want to know the length of the sides, I can square root the area and I get that the sides are 9 long because 9 times 9 equals 81. It gets a little bit funky when I try to do the square root of the next square because this square has an area of 2. And when I try to square root 2, I get an ugly number. In fact, if you type square root 2 in your calculator, it won't even give you a number. It'll just spit back square root 2 because it doesn't want to give you the ugly decimal that is the answer. So what happens, and first of all, that's not wrong. The sides of this square are the square root 2 and the square root 2. It's just not a nice number, so it doesn't turn it into it. What you're getting is what is called as an irrational number. So you'll get this sometimes when you're doing square roots. An irrational number, I'm just reading you this definition right here. It's a real number that cannot be expressed as a ratio of integers a over b. Instead, the decimal terminates, it does not terminate and it does not repeat. So that means that the decimal goes on forever without repeating. It goes on and on and on. So if I can write it as a integer over an integer, that makes it a rational number. If I can write it as a decimal that ends, that's a rational number. If it's a repeating decimal, that's a rational number. If not, then I get an irrational. So over here on the right, we've got a bunch of different numbers. 7329 is a number. I can write it as a fraction if I just put it over 1. So this is a rational number, okay? Square root of 4, if I type that in my calculator, I get 2. Well, 2 is just a number, 2 over 1, so that is a rational number. 0.5287593 is an ugly decimal, but it stops. It ends at a 3, so that means that is a rational number. The next one, though, 0.9583275 ... What that ... means is it's going to keep going and going and going, and it's not going to stop. So this is called an irrational number. Pi. You know that pi has decimal places that never end. That's because pi is an irrational number. 0.3333333. Even though the 3's go on forever, it's a 3 that repeats, and this one we can rewrite as 1/3 since that 3 keeps repeating itself. So this one is a rational number. 11 over 9, you have an integer divided by an integer. That's a rational number. Square root 2, not a rational number. That one is irrational. Now, if you type something in your calculator and like a square root number into the calculator and it just spits back the same thing, that's a clue that you're getting an irrational number, and you can just leave it written as square root 2. I'm okay with that number. You don't have to write the decimal down. You can leave it the square root of 2, okay? All right, now, next box before we get into some fun. Simplifying square roots. If you are starting with the square root of 50, if you type that in your calculator and hit enter, it's going to spit back 5 square root 2. These two numbers are the same. The number on the left, the number on the right are the same number written two different ways. Now, the reason that they simplify, and you don't need to know how to do this by hand because you've got those calculators. There's a reason why I picked the ones that I did. You type it in, you get an answer, and you copy it down, okay? So, but what is happening behind the scenes, what the calculator is doing is it's taking square root 50 and it's changing it to 25 times 2. And since we know the square root of 25 is 5, you can actually pull that out in front and you're left with the 2 on the inside. That's what the calculator's doing. You don't need to worry about it. You just need to be able to repeat it, okay? So if you type these couple of questions across the top, if you type them in the calculator, square root 90, it's going to spit back not the square root 90. It's going to spit back what? 3 square root 10 is probably what you're going to get. If you type in the square root of 162, you're going to get 9 square root 2. And again, these answers are great. You don't need to turn it into an ugly decimal. You could hit the best friend button and get the decimal, but I like these numbers. They're exact answers. They're good numbers. We like them. 3 square root 88. If you type this in your calculator, it should spit back, what? 88 is 4 times 22. So it's going to spit back 6 square root 22 is what you're going to get back for that one, I think. If I'm wrong, come tell me tomorrow. 2 square root 72. 72 is 36 times 2. So you're going to end up with a 6 that comes out since that's the square root of 36. So you get 12 square root 2. You don't need to know how that works. You just need to plug it in the calculator, get the answer. Square root 64, you should just get the answer 8, okay? Now, if you are doing square rooting with variables, we're really not going to do it very much this year, but just really quick so you know what it looks like. You square root them separately. So like you would square root 36 in your calculator, which turns into 6. And then you're left with the square root of x squared, which you already know those cancel each other out, so you get 6x, okay? The next one, when you square root 20, that turns into 2 root, 5? But then you have a x squared on the inside. Well, the opposite of x squared is square rooting, so those are going to cancel each other out, which means the x comes out here on the outside with the 2, and I usually write that 2x root 5. Again, not something you need to worry about too much, but I want you to see how it works. Square root 4x, the square root of 4 is 2. The square root of x, I can't pull the x out because x is not getting squared. All right, so a couple more examples. 9x, or square root of 9x squared. The square root of 9 is 3. The square root of x squared is x. Square root of 64x. Square root of 64 is 8. Square root of x is just square root of x. That does not simplify. Okay. Now, square root of 100 is 10. And then if I look at this x cubed and this y to the 6th power, these ones are a little bit tricky because I can also split those up into x squared times x, and the y6 can be y squared times y squared times y squared. So you end up with 10x with a y on the outside, and you are left with what's on the inside, just an x all by itself. So this one would be 10xy cubed on the outside, square root x on the inside. I'm not going to test you on that, but again, I want you to see how these ones work, okay? All right, we're going to skip that next example because I want to get on to what you need to know. The whole reason of knowing square root is so that you can solve quadratic equations, okay? Now, when we are solving, there's something I need you to make. I need you to add a little bit of a note here, and let's put it right underneath the solving equations. When you square root while solving, you get 2 answers, a positive and a negative answer. Now, let me show you what I mean. 8 squared is equal to 64. Negative 8 squared is negative 8 times negative 8. That is also 64. So if I'm going backwards, if I want to take the square root of 64, we usually just say it's 8. But it's actually, it could be 8, but it could also be negative 8. There's actually 2 answers to this question. Now, when I'm just square rooting numbers like we were doing up above, I don't worry about that negative answer. But when I'm solving an equation, this negative answer matters very much because what you've got when you are solving a quadratic equation, your equation is in the shape of a U. And so sometimes that U crosses the x-axis twice. And that's why you get 2 answers, negative 8 and positive 8, not just one answer, because you are crossing in 2 different places, okay? And we'll worry about that a little bit more when we get to graphing. For now, I just need you to know, when I solve an equation, so this first example, x squared equals 121, I'm just going to do railroad tracks to get x by itself. Well, the opposite of x squared is to square root this side. But if I square root the left, I have to square root the right. So on the left, I end up with x. On the right, I end up with 11. But I also could get negative 11. So I actually have 2 answers on the right-hand side. So my answer is x equals 11 or negative 11. We can also write that as x equals plus or minus 11. This is the more common way to write it because you're saying the positive and negative of the same number, okay? Now, 529 equals x squared. If I do railroad tracks and I square root both sides, I I should have maybe done this problem before because I don't know what the square root of 529 is. That would have probably been a good idea to prepare ahead of time. But don't worry, I'll find a calculator. But I've got x squared on the right. So the opposite of x squared is to square root. So that means I have to square root 529. And if I do that, if I type that in the calculator, I get the answer 23. So over here I have x. Over here I have 23. But I'm solving an equation, so I also have to write down negative 23. I've got two different answers. X equals 23 or negative 23. I could also write x equals plus or minus 23. Those mean the same thing, okay? All right, let's do the next one. X squared equals 200. Now, railroad track, I want to get x alone, so I've got to get rid of that square. So I'm going to square root both sides. On the left, I'm left with x. On the right, when I square root 200, I'm not going to get a nice number like 11 or 23. When I square root 200, I'm going to get 10 square root 2. But I need to remember I also get the negative version of that same answer. So I also get negative 10 square root 2. You don't have to make those decimals. You can go ahead and leave them just like that. So x equals 10 square root 2 or negative 10, whoops, I forgot the 10, negative 10 square root 2. Or you can write it x equals plus minus 10 square root 2. All right, moving on. These next ones, the x squared is not alone at the beginning of the problem. On this one, I've got this plus 12 going on. Now, just like railroad tracks, if I square root right now, I'm square rooting this entire side. I don't want to square root that entire side. I just want to square root this to make the square go away. So before I can square root, I've got a minus 12 from here and minus 12 from this side, which means I end up with x squared equals 49. Now I can square root both sides to get x by itself. And I end up with x equals, the square root of 49 is 7, but it's also negative 7. So x equals 7 comma negative 7, or you could write plus or minus 7. Means the same thing. Okay, 4x squared equals 100. I want to do railroad tracks, but I need to get x squared alone, and I've got to get rid of the 4 first. So I'm going to divide by 4, and I get x squared equals 100 divided by 4 is 25. So now I want to square root this side, square root this side, and I end up with x equals, the square root of 25 is 5 and negative 5. So my answer is x equals 5 comma negative 5, or x equals plus minus 5. Okay, last one. There's two things happening to the x squared. It's getting multiplied by 7, and we're adding 4 as well. So when I do my railroad tracks, I need to get rid of both of those numbers. So I'm going to minus 4 first. So I end up with 7x squared equals 182. And then I'm going to divide by 7. Divide by 7. So x squared equals, let's see, 182 divided by 7 is going to be 20, oh man, what is it? 182 divided by 7, it's going to be 20-something. I should know that one. 26, that sounds right. 26. Now when I square root both sides, I'm going to square root this side to get rid of the square. I end up with x equals, the square root of 26 is not a nice number, not at all. Like if you type square root of 26 into your calculator, all you're going to get back is square root 26. So here's how you write that answer, because remember, you've got the square root of 26, but you're supposed to get two answers. So your second answer is the negative square root of 26. You just put a negative out in front. So you could say x equals plus minus square root 26, just like that. Okay, homework. Flip your page over. You've got different questions on the back, and they should look just like examples that we did on the front. There shouldn't be any surprises there. And then there's a couple review problems at the bottom that I want you to practice. Make sure you have not forgotten how to do those things, because we're going to need to know how to do them going forward. So good luck. Let me know if you need any help.